Welcome back to another video. In this video, we'll be looking at metallic bonding. Okay, so we'll look into a few concepts, a few important concepts with regard to metallic bonding. So if you look at, so by the end of the video, you will be able to understand what a metallic bond or what is metallic bonding. And also we will look into the properties of metallic bonding. There are a few properties that you need to know and the reasons why they are able to possess such properties. So all of that will be discussed in this video. So the first question, metallic bonding is a new word. So we need to know what metallic bonding means. So metallic bonding, we know the meaning of bonding. So metallic bonding is a type of chemical bond. It's a chemical bond found in metals. So from the name metallic, you would realize that it is something to do with metals. So similarly, it is a chemical bond found in metals. So if you look at the periodic table, where do we find metals? You can find metals from groups 1 to 3, and also the transition metals, which is the D block elements of the periodic table. All right, we don't discuss it very much, but there are certain transition metals that are very important and we do discuss them. But our main focus will be on the metals that are available in groups 1 to 3. All right, so this metallic bonding basically consists of positive charges which are arranged in a lattice structure in a sea of delocalized electrons. So positive charges, we know what positive charges means. That means they possess a positive charge. Okay, we all know that metals are able to give away electrons. So when an element gives away electrons, they become positively charged. Okay, and then when we say a sea of delocalized electrons, so this word delocalize is a new word. So delocalize is a synonym for electrons that are able to move around. So basically another name to give for delocalized electrons will be mobile electrons, okay? So electrons can move freely, all right? And then we say that the positive charges are arranged in a lattice structure. So lattice structure means that they cannot be arranged like the arrangement of these positive charges. They're not arranged, here and there, one is up, one is down, after that. There's a particular regular pattern, and that pattern is followed throughout the bond. All right. And now we discussed about, there are positive charges, there's a sea of delocalized electrons. So positive charges have a positive charge and electrons have a negative charge. So obviously when these two meet, they will definitely have a force of attraction between them, because we know positive and negative attracts. All right, so that force is called electrostatic force. Okay, and these metallic bonding has a very strong electrostatic force of attraction, and with regard to that, it possesses various properties. Okay, so to explain better about this, we could use a diagram. Okay, so the next slide we have the diagram, and we'll look into the diagram too. So this is the basic diagram, the diagram that you see on the left of your screen. Okay, so the diagram on the left of the screen is just a basic idea of a metallic bonding, the structure of a metallic bonding. You can see the yellow color circles that are there. They are the positive charges, and you can see they are the pink color. The pink color balls are the delocalized electrons. So delocalized electrons, there are so many. So that's why we in the previous slide, we referred them as sea of delocalized electrons, which we say, which we want to specify that there are infinitely many electrons in the metallic bond. All right. Now, these, if you can see, these positive charges, they are arranged in a particular manner. Now, these delocalized electrons, they are arranged in a wavered manner everywhere. They are just scattered everywhere. But the positive charges, they have a particular pattern. That pattern is called lattice structure. Okay, be very mindful because these terms, lattice structure, we refer or we use in our science. I would say science vocabulary. Yeah, that's a good word. Vocabulary. Yeah. So now, when if you see this structure, okay, so there are positive charges, there are delocalized electrons. So obviously there is a strong uh, electrostatic force of attraction between them. Okay, so if you want to break this, if you want to melt them, or you want to do something, it takes a huge amount of energy to break them because there are a strong force of attraction between them. All right, so this is the basic idea. So if someone tells you draw uh, the metallic bonding in general, so in general this is the one. You have positive charges and you have these electrons. All right, delocalized electrons scattered everywhere, but the positive charges arranged in a lattice structure. Then, in case they tell you, okay, uh, you know, don't draw the general metallic bonding. Draw metallic bonding for a specific element, specific metal. So, in terms of sodium, say if they say okay, draw for sodium, you can see for sodium we are what are we doing? So sodium we know is in group one, so it acquires a positive one charge. So that's why we have put the positive one charge into this orange color ball. And around them, we can see there are delocalized electrons. All right. So here also you can see, you can notice very clearly that the positive charges are arranged in a lattice structure, but the electrons are scattered all over the place. All right. Then if they say, similarly, if they say for magnesium, similar, you will have the sea of electrons scattered all over the place, but the positive charges follow a regular pattern. And the pattern, you can see the positive charges, we include two pluses here. Why do we include two pluses? Because magnesium falls into group 2 and it acquires a 2 plus charge. Okay, so remember about this. Okay, it doesn't always become just one positive charge. It depends on the group the metal is in. Okay, so aluminium is in group 3, so it acquires a positive 3 charge. Okay, if you want to remind yourself how it acquires a positive 3 charge, I would say go back and refer to your notes where we did about writing chemical formulas, where we discussed about valency electrons. All right, so aluminium is in group 3. It has a positive 3 charge, so that's why we include 3 pluses within these green circles, and then the delocalized electrons are scattered all over the place, as it should be for a metallic bond. All right, so this is the basic idea. So if they even tell you, say they give you some weird metal, okay, if they give you a weird metal, say a transition metal, transition metals, they can have various amount of valences. They can be 2 plus, 3 plus, 4 plus. So in that case, they would be differently specifying you what is the charge, whether it's 2 plus, 3 plus, or 4 plus. Okay, but other metals which fall into group 1, 2, 3, you need to know whether they acquire a positive charge, positive 1 charge, positive 2 charge, or positive 3 charge. So except apart from that, the whole idea is pretty simple. So next, what we would look into is are the properties. That is the most important thing in any scenario in chemistry or in any other science course. You would definitely must need to know the properties of certain things, and why do those properties, why do those bonds or anything, why do they possess those properties. Okay, so the first property that we're going to discuss are, now these metallic bonds have very high melting and boiling points. Now why is that? That's a question straight away. They would ask why so. So in the exam they might tell you they have high melting points and boiling points, and they will say why is that? The reason is, think about this. Now this is the metallic bonding. The picture on the right that you can see, yellow color positive charges, and the pink color delocalized electrons. So now these guys, okay, they're oppositely charged. So what happens when they're oppositely charged? They would have a electrostatic force of attraction between them. The electrostatic force of attraction is very, very, very strong. Okay, so if attraction is very, very strong, so if you want to melt it, if you want to melt a metal, it's very difficult. Why is it difficult? Because there's a strong force of attraction, electrostatic force of attraction between them. So, so therefore, to overcome this strong attraction force, we need a high amount of energy to melt them or even to boil them. So that's why they have high melting and boiling points. So you can see in real life, if you want to try to melt metal, it takes a lot of amount of heat, right? You can't just I don't know, go to the kitchen and melt a metal. You can't do that. You need high and large amounts of heat to do that. Okay, so think it in a practical way. Okay, then the next property will be metals are malleable and ductile. So what does malleable mean? So these are two new words. Malleable means, so basically, if you can see, if you take a metal, okay, you take a metal, if you hammer the metal, you can see the shape of the metal would change. It won't change drastically. Like for example, if you have a rectangular piece of metal, you can't hammer it once and then change into a circle. Okay, but you can deform it. Okay, you can do that. You have seen maybe in car crashes. In car crashes, the structure of the vehicle changes, gets deformed. So why does it happen? Okay, so why does it happen? It happens because you can see these um, charges, these positive charges, how are they arranged? They are arranged in a lattice structure. Okay, so now when you apply a force, if you apply external force onto this structure, these positive charges can just slide over each other. So this sliding off over each other is the reason why it is able to uh, possess the property of malleability. Okay, and similar to ductile. Now ductile means you are able to draw them into wires. Okay, so now wires, if you can see, oh, there's cable wires, overhead wires, they are all made out of metals. You don't see them made out of plastic, you don't see them made out of wood. All they do is they use uh, metals, right? So that's, in that scenario, see the same thing. Okay, sliding over each other. Okay, so these layers can slide over each other, and therefore they are able to possess this incredible property of malleability and ductility. All right, then the next last two properties that we're going to discuss are, so metals, we know, are good conductors of heat, right? So for example, if you heat one end of a particular metal, and you touch the other end of the metal, within a short span of time you would feel the heat. All right, so that means heat is able to pass through the metal very, very quickly. So why is that? The reason is because of the delocalized electrons. These electrons, the delocalized, or in other words, they are mobile. They can move freely. So they move when heat energy is applied. These delocalized electrons, they gain those heat, and then they just pass it on very, very quickly, because they're able to freely move. All right, so that's the reason why metals are good conductors of heat. Similarly, we know metals are good conductors of electricity, right? So for electricity also, that's the same thing. If you supply an electrical energy to a metal, and what happens is the locality of electrons, the electrons are able to pick them up and then transfer it slowly and slowly throughout the metal. Okay, so from one end to the other end, uh, they can transfer the heat or the electricity very quickly, within a short span of time. Very quickly they can transfer, so they are considered as good conductors of heat and electricity. All right, so yeah, so that's it for this video on metallic bonding. So we discussed about what metallic bonding is. We discussed about the structure of the general metallic bonding, and then we discussed about the lattice structure of the positive charges. We discussed what the delocalized electrons do, and we discussed the in terms of specific elements, sodium, magnesium, and aluminium. And also we discussed about the properties, and we came to know that why metallic bonding or metals are able to possess those properties from these metallic bond. All right. So you are able to answer any question with regard to this. So hope you understood this, and I'll see you again in a another video. Thank you.